Alright, after 2 lessons on how to multiply polynomials, now we look at how to divide polynomials. And first, what we should do is remember how to deal with exponents like this, situations like this. From our exponent tricks, hopefully you remember that 5 to the power 8, which by the way means 5 times 5 times 5 times 5 times 5 times 5 times 5, 1, 2, 3, 4, 5, 6, 7, 8 5s, and then 5 times 5. That's what that means, right? 5 to the power 8 means all that. 5 to the power 2 means all that. And what you do is you cancel out any of the 5s. So here's the 5 canceling out with that 5, because 5 divided by 5 is 1. So that gets rid of those 2. And I don't know, pick who's this 5 going to cancel out. You can pick any one you like. Let's pick this one here. These 2 cancel out. What are you left with? 1, 2, 3, 4, 5, 6 5s. So you're left with 5 to the power 6. You can do it that way, or you can just realize the exponent trick. When you have exponents with the same base, you subtract the exponents. So 5 to the power 8 minus 2, 6. Either way you do it, 5 to the 6 is the answer. Same thing with this. I could write out 8x's divided by 2x's, and I'm going to cancel 2 of the x's from the 8, which is going to leave me 6. So it's x to the power 6. That's why x to the power 6 is that way. Why this rule works that way. If you don't want to do all that, just, again, same base, subtract the exponents. X minus 2 is 6, so it's x to the power 6. Alright, what about this? Actually just gave you the answer, but I'll explain why it's 4x squared. Should have erased that. Here, you just simply divide the numbers and treat them separately from the letters. This is how I would do it. 16 divided by 4 is 4. X squared, there's no other exponent down here that we can simplify this thing with, so it's just 4x squared. Done. What about this? 21y to the 6 divided by 3y squared. Again, if I wanted to, I could have wrote out 6 y's up here, 2 y's up there, and I could actually break the 21 up into its prime factors and crisscross and all that kind of stuff, but let's just do it this way. We have the numbers, treat them separately from the letters. 21 divided by 3 is 7. And then we're left with this, y to the 6 divided by y to the power 2. We're dividing, so we subtract these 2 exponents. It's 7y to the power 4. Finished. What about this, divided by the old-fashioned, old-school way, the elementary school style of showing it? If you can divide this way, or if you prefer to see it in a different way, the way that was above, you can rewrite it with this divided by term. So let's take a look at this here. Again, the numbers, 12 divided by 4 is 3, or you could have saw it this way as well. 12 divided by 4 is 3. And then with the x's, you have a 3, a 2. You're going to subtract those 2 exponents. 3 minus 2 is 1, so that just leaves you with x. Or again, you could have realized that going this way. 3 minus 2 is x. And then with the y's, you have a squared and an imaginary exponent of 1 there. So it's 2 minus 1, which is 1. Now, do you have to put the 1 there? No. You can just leave it as 3xy. And that is as far as you can go, so that would be the answer. Okay. So now we change things up. What if you have a binomial? All these above were monomials divided by another monomial, and that's pretty straightforward. Here you've got a binomial divided by something. And the way you read this is 9 plus 15, and the whole thing is divided by 3. Actually, each term is divided by 3. So it's probably better if you have something like this to rewrite it like this. 9a is being divided by 3, and 15 is being divided by 3. So we're just splitting it up. And then we just do any dividing that we can. The a's, nothing can happen with them because there's no other a down here, but 9 divided by 3 is 3. Don't forget the a. Plus 15 divided by 3 is 5. There's no variables. The answer is just 3a plus 5. Now, if you can do that in your head from there without having to separate it out, that's fine. But just realize that, yeah, when you have two terms here, each term is being divided by 3. That divided by 3 and that divided by 3. So either separate it out or do that in your head in one step. Up to you. How about this? Again, rewriting it. So let's do it. This is being divided by the negative 3x, and this is being divided by the negative 3x. So 24x squared all over negative 3x. And now, people keep asking, is this a negative sign or a minus sign? And I always say both, and people look at me confused. You could treat this, you can say that it's plus negative 9x over here, or we can just put the minus right there and just call this 9x. It still belongs to it, to the 9x. And we're dividing by negative 3x. So you can do it that way, or again, you could put the minus sign up here and go like that. Because remember, double sign means a minus anyways. I hope I didn't confuse you by all that. So here, again, the numbers, we work with them. 24 divided by negative 3 is negative 8. X squared divided by x, we're subtracting the exponents. 2 minus 1 is 1. No one puts the 1 in, that's lame. Just leave it as negative 8x. And then over here, you've got negative 9x divided by negative 3x. Well, let's do the numbers first. Negative 9 divided by negative 3 is positive 3. And x divided by x, the x cancel out, or if you don't believe me, use our exponent rule. X to the power 1 minus x to the power 1, the 1s become 0, and it's just done. Technically, x to the power 0 is 1, but 3 times 1 is 3, so you just, yeah, there's your answer. How about this? Again, these three terms in this trinomial will be all divided by the 5x squared. So we want to rewrite it. This becomes 20 x to the power 4 divided by 5x squared. And then, again, you can leave this minus down here, and then just put 15 divided by that, or you can leave that minus sign with it when you write it down and put plus. I don't really care what you do. Let's just, for showing it that it's different than the other one, put a minus sign there, and then just bring down the 15 x to the 3 over 5x squared, and then plus 5x squared divided by 5x squared. And we do it. 20, do the numbers separate from the exponents. 20 divided by 5 is 4. X to the power 4 divided by x to the power 2, subtract the exponents, is x to the power 2, because 4 minus 2 is 2. Minus 15 divided by 5 is 3, and again, the x there, and then x cubed minus x squared, sorry, divided by x squared. You are subtracting the exponents, you just get x, because it's x to the power 1, you don't need to put the 1 there. And then over here, you have 5x squared divided by 5x squared. Now some of you might be thinking, oh my god, they cancel out and they leave nothing. Well, they don't leave nothing. They actually leave 1. Something divided by the exact same thing equals 1. 5 divided by 5 is 1. X squared divided by x squared is 1. So you get 1. You gotta put the 1 there. Okay, so that's the answer to that. Always double check to see. You might be able to collect like terms at the end of some of these equations. You couldn't do it here, circles and squares. You couldn't do it here, as they're all circles and squares and triangles, so that's it. Alright, how about this doozy? Probably would help to rewrite it. So that is divided by that, that is divided by that, and that's divided by that. So x cubed y squared divided by 4x squared y. Let's leave the minus sign here and go x squared y to the 4 divided by that same 4x squared y. And then this divided by that, 12x to the power 4 y squared divided by 4x squared y. And from here, we just bring it home. Now, look at the numbers we have here. What imaginary number's in front? It's an imaginary 1. 1 divided by 4. Now, you can put 0.25 if you want, but you can just write 1/4 as well. Just leave it as 1/4. And then the x's, x cubed divided by x squared. We're subtracting these two exponents, so that just means x to the power 1, which is just x. And here, y squared minus the imaginary 1 there. 2 minus 1 is 1. So it's just y to the power 1, which is just y. Minus, here, there's no fraction to worry about. 8 divided by 4, is 2. The x squared minus the x squared. So the x's are gone, just becomes 1, which is 2 times 1 is just 2, so just leave it. And here you have a y and an imaginary 1 here, so you subtract these two exponents. 4 minus 1 is 3, so it's y to the power 3. Hopefully you realize, the x squares were gone, they're cancelled out, which, like I said above, does leave the number 1, and these things are all multiplying each other, by the way, right? There's nothing in between, they're multiplying. So if you want, you can put a 1 in there, but what's 2 times 1? It's 2, so there's no point of putting in the 1. And then here, the numbers 12 divided by 4 is 3, and then x to the power 4 divided by x to the power 2, subtracting, you get x squared. And then y to the power 2 divided by y to the power 1, imaginary 1, we're subtracting 2 to the power, 2 minus 1 is 1, which is just y. Any like terms here? x, y, y cubed, x squared, y, they're all different, so you cannot collect them, and that is your final answer. Okay, if you need to pause, rewind, of course, do what you gotta do. Here are your skill testing questions. 3 of you to do there. Enjoy. Bye-bye.